Today we will study a digital to analog converter and analog to digital converter. Okay. ADC means analog to digital converter. Analog signal is given as an input and the ADC converter convert into the digital outputs, means digital bits. Similarly, in the digital to analog converter, a digital signal is given as an input to DAC and DAC will convert it into analog output. First of all, as we know that, for example, I will give you, when we streaming a song in a mobile phone or in a cell phones, what we are listening is an electrical signals. So, as an input, a mobile phone is converting a digital signal to a analog signal. So, it's a best example for the DAC. Now, for the ADC. Okay, when we are talking on a cell phone or on a microphone, it converts a analog signal is going to the transmitter. Okay, and the transmitter will convert or a microphone will convert a analog signal to a digital signals. Okay, at a receiver there is an ADC which is converting a analog signal to the digital signal. Now, first of all, we will study about the digital to analog converter with binary weighted resistor. Okay, how it's the digital to analog conversion is conducting by a use of binary weighted resistor. So this is a diagram. It is a op-amp working on an inverting mode, V2 voltage, V1 voltage, IB, resistance, feedback resistance is 1 kilo ohm, power supply is given, DC power plus 15 volt, and we have to find out the voltage. These are the binary resistors. 4 resistors are connected, 10 kilo ohm, then R by 2, 5 kilo ohm, R by 4, 2.5 kilo ohm, R by 8, 1.25 kilo ohm. There is plus 5 volts power supply is given. Okay, and here it is a grounded. So these are the switch. The one is switch for the power supply and another for the grounded. If we connect B0 by a 5 volt, okay, and B1, B3, B2, B3 are connected to the grounded. Okay, if B1 is connected to the grounded supply, switch is for that, means it's connected to the grounded. This is also connected to the grounded, and this is also connected to the grounded. So what will be here? The current will be there, and voltage will be a 5 volt. Okay, so the current will be at here will be a current will be Ohm's law, we will use it, V is equals to IR. So what is the current? 0.5 ampere. Okay, so as the 0.5 is going to the current here also, so what is the output voltage? V0 is equals to 0.5 into 1 kilo ohm, and here is the negative means the answer will be minus 0.5 volt. What we are getting out an output V0 is minus 0.5 volt. Similarly, if we connected B0 to the ground and B1 is connected to the power supply, listen to me carefully. If B0 is connected to ground, B1 is connected to the 5 volt and B2, B3 is grounded. So what will be the here will be a voltage will be 5 volt. So the current will be 1 kilo ampere. So the current will be 1. Similarly, here also the 1. So output voltage, what we get it at minus. Next for the minus 1 volt. Similarly, what we are seeing that if we connect it as a B2, the output voltage will be, and otherwise B0, B1 and B3 are connected to the grounded and B2 is connected to the supply. We will get a output voltage as minus 1.5. So there is 0.5 difference between them. Here we are just studying about the digital to analog converter. As we know that we are using a 4-bit, okay, with binary weighted resistor by using a resistors of 4 bits. So possible combination will be 16 because the digital have a 2 form 0 and 1. So 2 to the power 4 is equals to 16 combination we will got it. So at here the number of binary inputs are 4, so converter is called 4-bit converter because there are 2 to the power 4 is equals to 16 combination of the binary inputs B0 to B3. So there will be a decimal equivalent. Here we make a table. 0 to 15 means 16 combinations are there, and inputs are B0 and inputs are B3, B2, B1, B0. Output voltage will be at 0, 0 we are getting 0 output voltage. At here 1, sorry, it's a 5 because why we are writing 5? Because 5 volt power supply is given. So at a B0 we are giving a 5 volt. Now here what we get it at a 1 means minus 0.5. When we connected a B1, there we got it minus 1. Then when we are connected B means we will get these outputs, okay, 0, 0.5, 1, minus 1.5. So the maximum voltage will be minus 7.5. okay, we will when we connected B0, B1, B2, B3 are connected to the 5 volt supplies. So what will be the equation will be here? V0 is equals to minus RF B0 upon R plus B1 upon R2 upon 2 plus B2 upon R upon 3 plus B3 upon R not R upon 3, here R upon 4 and R upon 8. This is the equation when we are connected these alls to the 5 volt supply. So here we will get a V0. V0 is calculated when we summed out it and divide, okay, and calculating the current will be here. So we will get an output voltage. So this is, now what is the graph we will plot? The graph is plot between the decimal equivalent and the output voltage. Okay, these are the voltage. The maximum output voltage minus 7.5 and 0 to 15 are the decimal equivalent. So at 0, 0 we are getting a 0 volt, minus at a 1 we getting a minus 0.5, 2 minus 1. So we will get this type of analog signal, okay, at a maximum of minus 7.5. So here it is a analog signal. Now we will study R2R network. Okay, why we will study? Because in binary weighted resistor only we can use only a 4 bits, means B0 to B3. Now we have to make a more possible combination, so and we have to use a more number of bits. So there is an introduction of resistor R2R network in digital to analog converter.